Chapter 7 review exercises, question E65, and we have a student commuting to campus each day of the week, to and from campus. This was interesting to me because this is one of the first statistical studies I actually did, although my question of interest was which way to work was quicker. So we have the mean and variance of the morning commute times. Well, I've already listed out what was given in the table here, and then we can get the mean fairly quickly by just taking average of the set of numbers. Oops, I think I grabbed too many there. Yep. Okay, there we go. So that's our average. And maybe just put a little line here to show the cutoff there. And for the average there, we can get 8.2. So the mean is 12.8. Let's calculate the variance. Now, as soon as I type in VAR, my first two options are var P and var S. In other words, variation of the population and variance of the sample. So what do I have right here? Do I have a population or do I have a sample? Well, because we're looking at the entire week of data, then we can consider it as a, oops, I'm in the wrong cell, sorry. So variance, we can consider it as a population variance. So I'm just going to grab these here. And what is the difference again? Well, remember the population, if I look at the formula, it's going to divide by n, whereas a sample variance would divide by n plus 1. And we had that exercise earlier in the chapter that showed why we divide by n plus 1 when we're working with a sample. So of the afternoon commute times then, I just extended my formulas in both cases to get 8.2 and 5.36. And here's where we start to get into the interesting stuff. So if we select a day at random from this population, so again our population is 5, our sample size is 1 in this case, and find the total commute time for the day, what are the mean and variance of the distribution of this commute time? Well, what we want to do first is get the total commute. Woo! That's not what we want to do. We want to get the total commute time for each day by taking a sum of the morning and afternoon. Notice I did that backwards, but that doesn't really matter. And so we get the total commute time for each day, and then I'm just going to extend this formula. What it's going to do is take the average of these times. I'm going to do the same for the variance here. Okay, and so the mean out of those is 21, the variance is 7.2. So can I do that? Can I, well, okay, obviously I can do that. Let me address part C right now rather than later. So are the answers in part B equal to the sum of those in part A? In other words, is 21 is the mean or the expected total commute time the same as the mean morning time plus the mean afternoon time? And yes, it is. 12.8 plus 8.2 gives us 21. Is the variance of the total commute time the same as the variance of the morning plus the variance of the afternoon? And in that case, it's not. And why is that? We can add variances, remember, but what's the condition? We can only add variances when these two variables are independent. If there's any correlation between these two, in other words, if these two variables, x and y, or morning and afternoon, or whatever we're looking at, if there's some correlation between the two, then we can't simply add the variances, unfortunately. There's a third term involving covariation that we need to take into account. So the important part there is that the means can be added even if they're not independent, whereas the variances can be added only if they're independent, which they are not in this case. And so we have a no for part C.